In this segment, we are going to generate voice responses whenever an AI agent makes a move. Okay, so let me show you what's coming. Whenever I make a move, I'm expecting a comment from this AI agent.
Oh, Summit, you are such a loser. Nice try, but I see through your feeble attempt.
Okay, it's not that bad, but it could be better, right? I created a GitHub repository for you where this entire project is divided into 6 different steps. Each step has their own branch and each branch has 2 versions, starting version and end version. I'm going to make changes to starting version and all those changes will be available in end version. The reason I did that is very simple. I want you to experiment with each individual step. So first we are going to understand how this AI agent joins an existing meeting. Then we are going to understand how we can keep the server running in background. Then we are going to receive clients move on server side so that we can manage one state which is true for all the other clients. Finally, we are going to generate server responses and then we are going to add ElevenLabs. We are going to use ElevenLab to generate voice responses. And finally, we are going to make this game even more interactive where an AI agent is talking to us in real time. So let's start with very first step, which is joining an AI agent to an existing meeting. Alright, we can start with very first step, which is joining an AI game agent to a live meeting. Both client and server, they are disjoint from each other. Yes, they are collaborating, but they are collaborating through VideoSDK server. This session is first started by client, and when this button is clicked, we want to join a second player to this meeting through our server. So from server, we have to create an instance, or we can say some reference or some pointer to this existing meeting. I think that's the right way to put it. This client need some credentials related to this meeting. That's why we are making this post request where we are sending meeting ID and authentication token. uh, okay, so right now I am in starting version of this repository, which is joining AI agent, and all the changes made to this branch will be available in end version. Also, to join an AI agent to existing meeting, we have to utilize VideoSDK package. Using VideoSDK, we can create basic, like we can set basic settings related to meeting, like participant name, their mic configurations, and we also need meeting ID and authentication token so that we can point to right meeting. Next, we can create an instance of existing meeting. Then we can call this method join to actually join that AI agent. It's very simple, right? So if you look at that repository, we don't have this file called requirements. So in this file, we can specify all the packages we need. We need fast API so that we can build API application. We need UV cone, which is an ASCI server. It is going to serve our API application. And obviously video SDK for creating pointer to existing meeting. First, let me show you a simple get request, how fast API work. So app is an instance of this API application, and here we can like create a simple get request. Whenever client makes a request to this endpoint, we are going to send this JSON response. So let me show you how it work. Here I'm executing this run method from UVCon package, and let's run this server. Okay, maybe I have to spell it correctly. Now let's see, our server is running on port 8000 and this is the endpoint. We got this response, server is running perfectly. Next task is quite similar, but here we have to create a post request. So we also need a meeting request configuration. So it is extending this base model. It is used whenever we need like what parameters we are expecting in request body. And we also created a class called AI agent. Here we can write all the logic related to our AI agent. Like we created this method where we are calling this initialize method from video SDK. And in this meeting configuration, you will see all the settings available to you. So we are going to look at some other setting later in this video. All right, so let's save the changes. And we also need some course related settings so that our client can make successful request. Okay, I think that's all we need. As you can see, we are creating an instance of this AI agent and we are setting it to some global variable so that we can use it again. And finally, we are calling this join method and we are sending this response that AI agent joined successfully. Okay, let's restart the server. When I click this button, I'm expecting some other participant in this session. There you go. An AI agent joined successfully. Next task is to keep this server alive. Let's see how we can achieve that. After AI agent joins successfully, I want to keep this server running in background so that I can do other processing. So I will be using ElevenLabs, some LLM model and STT model. So you can imagine why I want to keep this server running. So I want to create some method where the server is running continuously. So I created this function server operation and I transferred this logic of joining AI agent to this function. As you can see, I'm calling this join method. And after all the processing is done, and when I no longer need that AI agent, I can call this leave method. So we have to make few changes to this AI agent class. Currently, I'm using this local variable to hold this instance. I have to create a global variable which is agent. Next, we have to define a function to leave that agent from current session. That's all we need to do. And finally, we have to add this function in background. To do that, we can use background task class. As you can see, after client receives some response, we want to keep a certain function alive. So in this request, we can add other parameter which is background task, and we can simply call this add task method. The way it work is like this. First we have to specify that function name and parameters it receive. Okay, let's restart the server and let's try to join that AI agent again. So I'm in starting version of this running tasks in background, and all these changes will be in end version. Okay, so AI agent joined successfully. This function is running in background. Our next task is to receive a client's move. Whenever clients make a move, we want to receive that on server side. On server side, we want to also generate a server response. Okay, so let's start with next task. In this segment, we are going to keep track of all the clients move on server side so that we can have one state which is true for all the other participant. We know that both client and server, they are disjoint from each other. They are collaborating through Video SDK. So we can make use of public subscribe feature from Video SDK where a client can subscribe to one topic. Then it can send and receive messages on the same topic. Right now, I am interested in receiving client's message. So if you look at this code on server side, I mean on client side, I subscribe to this game moves topic and I want to do something like that on server side. So I created this class which is game event handler, and it is extending this meeting event handler class from Video SDK. Because this AI agent is a local participant according to this server, we can listen to all the local events that are happening in current session for this AI agent. If you look at this I mean this meeting event handler, you will find other methods that you can override. Right now, when this AI agent joins this meeting, we want to subscribe to one topic, which is game moves. We can first we have to prepare this publish configuration. Then we can simply call that method, which is the subscribe method on this current meeting instance. Okay, so all we need to do here to call this subscribe method, and we have to specify this pub sub configuration. Here inside this pub sub subscribe configuration, you will find a callback function where we are going to receive client messages. So here we are going to receive client messages. Inside this data, we can access that client message. So this data is a dictionary type, so we can access this message. And then we have to attach these game events to this current meeting instance, which is this agent. Yeah, that's all we need to do. Now we can restart our server. I think everything should work fine now. So let's rejoin this game. Whenever I take a move, I am expecting it on server. As you can see, I received this client's move. My next task is to prepare a server response, and then we are going to generate audio responses using ElevenLabs. Our next task is to keep track of all the clients' move, and then we have to predict next position that AI agent can take, because this is not a complex game. So right now we are utilizing large language model to predict next position. Later we are going to generate comments that AI agent can make using same large language model, and finally we are going to use ElevenLab to convert them into voice responses. So in this segment we will do something like this. So I'm taking a move, so this move is received on server side, and server is predicting this next position that AI agent can take. For example, I took one more position, so it is predicting this next position. Right now it is not playing that great, but by the end of this video you will see it will be more interactive. Okay, so right now I am in starting version of this send server responses, and let's see what are the changes that are made to this current branch. Previously, we subscribed to one common topic, which is game moves, and we were receiving clients' responses in this callback function. This game could be in three state. First, nobody won this game, so it's a draw. Second, somebody won this game, and third one, this game is currently active. Both client and server, they are taking their turns. So it's client's responsibility to inform server about this current state. So if you look at this client component, and if you check out this publish method from pub/sub feature, you will find three different value of this type. First one is game over, that means somebody won this game. Second one is reset type, and third one is move type. So in this message here we are also going to get this type parameter, and based on that we can decide whether to make use of this large language model or not. So here in this prompt, so I'm making use of GPT model. I created this prompt where I'm uh, telling server that this is the current situation of this board. You hardly going to see a server which is stateful. So this server is already running, I mean always running in background, and we are keeping track of this game state where we are keeping track of all the moves that client and server are taking, active player, winning state, and whether game is over or not. So it's a stateful server, and we are informing this large language model about current status of this board. and we are telling them these are the position that client has taken, and only thing we want from you is next possible position in this board. This is a simple game. Imagine a game which is really complex. In that case, making use of GPT can reduce a lot of computational tasks. So traditionally what we do, we make use of some algorithm to achieve this task, but we don't need to do that. We can make use of some modern solutions. Okay, so I made few changes to this callback function. Let me show you. So in this message, we are getting that type parameter from client, and we are looking at its value. If it is a reset type, we are going to reset this server state, which is, I mean, this game state. And if it has a type of move, first we are going to validate this move. So we are going to make some boundary check based on this current state. Maybe maybe client has taken a move which doesn't really exist. So we are doing some boundary checks, and then we are updating this board, and then we are checking whether there is a winner or not. So these are all the winning combination in a tic-tac-toe game, and then we are uh, like informing our client that somebody has won this game. If there is a no winner, in that case we can make use of large language model, and we can update this current game state. Okay, so if you want to look at all the changes that are made to this branch, I mean, this is the starting version. You can check out this end version, which is so this is the end version of send server response, and you can check out latest commit, and you can see all the changes that are made to previous branch. So far, we built an AI agent that is playing with us, but it is not generating any voice responses. And that is something really missing in this game. So, in this segment, we are going to generate voice responses whenever an AI agent makes a move. And in last segment, we are going to add real-time communication so that we can turn this uh, dumb-looking bot into some real human. Okay, so let me show you what's coming in this segment. Whenever I make a move, I'm expecting a comment from this AI agent.
Oh, Summit, you are such a loser. Nice try, but I see through your feeble attempt.
Ah, okay, it's not that bad, but it could be better, right? So this AI agent doesn't have access to media devices. We are human. If we are part of an online meeting, we do have access to microphone and a webcam, but this AI agent doesn't have access to that. To bridge that gap, we are going to utilize ElevenLabs. Right now, I am in starting version of this branch, which is ElevenLabs voice responses. Let's see what are the changes that are required to generate AI voice responses. Now let's look at all the changes that are made to this code. So previously we were just predicting next position. I made few changes to this prompt. Now I also want a comment from this GPT model. So here I'm also generating a comment. Next, as you can see, I was just returning this AI position, but now we have both AI position and AI comment. So from this response, I want to access both AI position and AI response. Next, so this function generates server response. It was returning only the next predicted position, but now we want to also return this comment. And if you check out this AI agent class, you will find there are few changes that are made to meeting configuration as well. So here we added one more setting, which is custom audio track. Basically, we are handing it over to ElevenLabs. So we are passing this AI comment to ElevenLabs, and then ElevenLabs is generating audio chunks. So all those audio chunks are collected. So I created this class, which is custom audio track, where we are collecting all the audio frames, and then we are converting them into a suitable format that uh, so that we can stream it to VideoSDK network. Okay, so you can check out all these changes, and there is one more change that is made to this generate AI move function. So here we accessing that AI comment, and then we are handing it over to ElevenLabs. So these are all the changes that are made to this current branch. So if you want to check out all the changes, you can look at latest commit of this and version of ElevenLab voice responses. Only missing piece in our game is to have real-time conversation with AI agent, and we can bridge that gap by making use of speech-to-text model. We can utilize Deepgram's speech-to-text model, where we are accessing active speakers audio stream, and then we are going to hand it over to Deepgram's STT model. So I created one video which is dedicated to Deepgram, so how we can utilize it and how we can generate text from voice. Okay, so if you check out this AI agent class, I created one more class which is participant STT event listener. It is extending video SDK's participant event handler. Previously, we talked about meeting event handler where we are listening to all the local participant event. We can also listen to remote participant events. Whenever a participant joins an existing meeting, we are attaching this remote participant event listener to that participant so that we can listen to their events. So whenever they enable their audio stream, we want to access those audio stream and then we want to hand it over to Deepgram, and Deepgram is going to generate audio track for us. We are receiving those audio track in this callback function, and you can check out this code how it exactly work. If you want to understand in great detail, you can check out this video. Okay, so you will find one more change which is so I also added this function where we are also generating real-time conversational response. Let me start with the demo. Hi, are you ready to lose this game?
Why don't you start making your move rather than asking stupid questions?
Okay, I'll go first.
I'll take positions. Always thinking ahead, aren't I?
How about
Nice try, but I see right through your tactics.
how about this position?
Huh, I knew you were such a loser.